Hi students, welcome to this course, PLC Automation, an Introduction to Programmable Logic Controller. I am Professor Yao. The keywords: a pen spray, a sensor, the count and time operation. This example is for a timed process that occurs after a certain process count is reached. After a count of 15 from a sensor, a pen spray is to run for 25 seconds. Figure 10.5 shows a program that accomplished the count and the time operation. This is a program for counter and a timer combination. Example 5. The keywords: counting period, a delayed counting period, to start counting input pause. The fifth example shown in figure 10.6 is for a delayed counting period. In this process, we do not wish to start counting until 1 hour after the process starts. A timer output contact in the timer runs line closed after the time period. The closure then enables the counter to start counting input pause. After a count of 150, the output comes on. This picture shows the program for this application. Example 6. The keywords: the product flow rate is a 60-second time interval. The process starts over. Figure 10.7 is a ladder diagram scheme for obtaining the product parts flow rate. The timer and the counter are enabled at the same time. The counter is paused for each part go past its sensor, which is connected to in number 27. The counting begins and the timer starts timing through its 60-second time interval at the same time. At the end of 60 seconds, the timer's count data line is opened by a normally closed timer output related contact. Pause continue but do not affect the PLC counter. The number of parts for the past minutes are now recorded in counter register holding register 106. The part count for the minute can be recorded manually or by a computer technique, and it will remain in holding register 106 until in 60 is opened and the counter and the timer are reset. After in 60 is reclosed, the process starts over. This picture shows the PLC program, read per time period program. Troubleshooting questions. The keywords: misprogramming, malfunction, the pilot light, goes negative. The 25-second interval. Number 1. Referring to figure 10.2, example 10.1, the counter counts to 1 and a reset as the input goes on and then off. Number 2 refers to figure 10.3, example 10.2. The pilot light never goes on even when the designated count is reached. The pilot light never goes out. Number 3 refer to figure 10.4, example 10.3. As the process progresses, the count displayed in holding register 101 does not change. The count displayed in holding register 101 goes negative. Number 4 refers to figure 10.5, example 10.4. The display goes on when the control circuit is turned on. The display doesn't go off after the 25-second interval. The display never goes on. Number 5 refers to figure 10.6, example 10.5. The count starts after 6 minutes, not 1 hour. The counter does not count. Exercise. Program an automatic control for the system shown in figure 10.8. The keywords: a stacker, conveyor, paint, starting stacking plywood sheets, stack height, a height sensor. When the on button is pushed, a stacker starts stacking plywood sheets at position A. Stack height is controlled by a PLC counter function, not a height sensor. When 12 parts are stacked, the conveyor goes on and moves the stack to position B. A sensor is used to stop the conveyor at B. At B, paint is applied for 12.5 seconds. After painting is complete, the conveyor is restarted manually. The conveyor then moves parts to position B at position C. At position C, the stack stops automatically and the stack is moved manually. The stop button stops the process anytime it is depressed. Assume that only one stack is on the conveyor at a time. Add the limit switch and other devices as required. This picture shows the layout of the paint and conveyor system for exercise number 10. Homework: handwriting all keywords and submitting them to Coach Facebook. Just do the online quiz and see you next time.